Hello teacher, in this video I will give a present about degradation behavior of natural fiber reinforced polymer matrix composite created by Sasithon, Siangchin and Teeratada Yanwattana. Table of contents: the first, introduction; second, objective; third, experimental; fourth, result and discussion; and fifth, conclusion. Introduction. In this research, the improvement in the biodegradability of PP was observed by blending it with small addition 5% of wood sawdust and with flow. The developed composite material is then exposed to the open atmosphere, moist soils, water, and dry solution for a period of 50 weeks. They look at the change of composite material in degradation, and the change in boil level can be seen by FTIR. The change in tensile property can also be measured by tensile testing. The second, objective. Improvement in the biodegradability of PP was observed by blending it with small addition 5% of wood sawdust and with flow. The developed composites were then exposed to various environmental conditions, namely exposure to the open atmosphere, moist soil, water, and dry solution for a period of 15 weeks. Third, experiment. Materials. The PP in the form of homopolymer pellets had a specificity of 0.91. The wood sawdust matched 80 to 100 used was medium wood. Polyester and methanol were also used during the composite preparation to ensure uniform and adequate mixing. Natural fiber preparation. The sawdust and wood flow were dyed in a furnace at 80 degrees Celsius for 24 hours to remove moisture and any volatile impurity present. Fabrication of pure PP wood sawdust composite, and PP with flow composite. The PP and the natural fiber 5% by weight were mixed with polyester and methanol. The mixture was then heated in the furnace at 1100 degrees Celsius of 20 to 30 minutes to remove moisture. Hot press into sheets measuring 20 to 100 mm multiply 20 to 100 mm multiply 3 mm according to the heating cycle. Figure 1 is heating cycle of hot press. Preparation of sample for exposure to degradation condition. The sheets were then cut into 115 multiply 20 multiply 3 mm weathering sample for exposure to the degradation condition for a period of 15 weeks. Figure 2 sample preparation for weathering. Visual inspection after exposure to decomposition condition or the sample is examined for indication for opacity and turbidity that can indicate surface deterioration. Fourier transform infrared spectroscopy obtained using a FTIR spectrophotometer. The infrared spectra of the sample before and after exposure to the degradation condition. These were compared to determine the change in chemical bonding nature after degradation. Tensile testing following ASTM D63801. Test of the sample before and after exposure to the degradation condition at a cost head speed of 4 mm per minute and 10 replicate sample. The average volume were reported. Scanning electron microscopy. The surface morphology of the fracture surface of the tensile specimen were examined. The sample were scouted, coded with gold and observed at various magnification length from 200 to 3000. The fourth, result and discussion. Visual inspection result. After a period of 15 weeks of exposure in the degradation condition, samples with a symbol are those that are dissolved in saline, and those without the symbol are those that have been exposed to weather. Sample 1 pp mixed with wood sawdust show more degradation than sample 2 pp material mixed with wheat flour, and sample 3 containing pure pp were not affected by any degradation. Tensile test result. The tensile strength of the as received pure pp was found to be 32.1 MPa. However, addition of both wheat flour and sawdust to pp decreased its tensile strength to 29 MPa and 26 MPa respectively, and confirmed by other research. This is mainly due to the intersurface adhesion between the pp hydrophobic polymer matrix and the hydrophilic lignocellulose filler. This makes it inefficient to transfer state between the two phases of the material. pp mixed sawdust has less tensile strength than pp mixed with flour because sawdust contains hydrophilic substances such as cellulose and hemicellulose, which accelerate microbial attract and degrade faster than pp. pp blend with wheat flour and pure pp containing material are not affected by any degradation, so the effect is almost intact. The bar chart in Figure 5 and Figure 6 illustrate the change in the tensile strength of the composite in the various degradation conditions.
SEM analysis or scanning electron microscope analysis. The figures are showing below how the tensile specimen fracture. Figure 7a. The fractures surface of pure pp are characteristic of the brittle fracture with caved pan. Figure 7b. The fracture surface of both composites, especially the pp sawdust composites, reveal the presence of voids. In addition, with carry indicates the pure interaction between the non-parametric and parametric fillers and can expand decrease the tensile properties of the composites. Figure 7c. Both composites reveal the presence of localized fibril, which suggests the plastic deformation of the matrix as shown below. FTIR or Fourier transformation infrared spectroscopy analysis. Analysis of FTIR spectrum of all the samples before and after exposure to degradation conditions showed that the results were in parity with the tensile test with visual inspection outcome, which all the evidence pointed toward and fact that most degradation occur in the sawdust composite exposed to by, followed by composite bird in the moist soil. The pp sawdust composites exposed to by solution revealed that the disappearance of peak at 1725 cm power minus 1646.9 cm power minus 1 and 1T76.6 cm power minus 1. Figure 8, which positively indicates the dislocation of the bonds carbonyl, carbon-carbon double bond, and the methyl group, respectively. Spectra of the sample exposed to moist Soil show disappearance of peak at 1725 cm power minus 1 and 1650 cm power minus 1, whereas the sample exposed to water revealed disappearance of peak at 1725 cm power minus 1 and comparative attenuation in the intensity of the other peaks. The spectra of the sample exposed to the open atmosphere showed less change. Furthermore, pure PP samples show no visible change in the spectra before and after exposure to any of degradation conditions, thus confirming the non-biodegradable nature of PP.
Fifth, conclusion.
The addition of sawdust and wheat flow to PP has evidently increased its biodegradability, which is apparent from the reduced tensile properties in the composites. The disappearance and attenuation of the infrared spectral peaks and visible creasing of the sample after exposure to the degradation condition. The most pronounced degradation was observed in sample exposed to brine. The solution followed by the samples buried under the moist soil. This can accounted for by the presence of the highly corrosive chloride ion in the brine solution and the presence of microorganisms, bacteria, and or fungi. In the soil, the composite width is because of the higher water absorption ability of the sandwich in the comparison to wheat flow, which facilitates an increased rate of degradation of microbial attack and hydrolysis.